Hello, so in this video I'm going to be discussing how we can reduce cognitive load when learning and teaching maths. So what actually is cognitive load theory? Well, recently it's been described as the single most important thing for teachers to know. Okay, so cognitive load theory is the idea that there's a limit to how much new information the human brain can process at any one time, which seems quite reasonable. To be more specific, some studies have suggested that learners can generally process up to 4 new pieces of information at one time. Therefore, once a pupil's working memory reaches that cognitive load, no learning takes place. So when we actually stop and think about that, that's incredibly important, and when we're planning and teaching our lessons, we should be considering the cognitive load that our pupils are experiencing. So in this session, I'm going to be talking about 2 types of cognitive load. So the first one being intrinsic load and the second one being extraneous load. So let's focus on intrinsic load first. So what actually is that? Well, intrinsic load, that's the perceived level of difficulty that a pupil would experience when attempting a problem. 1 plus 1, most pupils would straight away know that the answer is 2. This is a low intrinsic load because there aren't many steps, there's not much they really need to do. As long as you can count, you can pretty much answer this question. However, let's consider increase 50 grams by 20%. So, the intrinsic load experienced on this problem really depends on the pupil. So some pupils might approach the problem something like this. So they might start by calculating 10%, multiplying it by 2 to find 20%, which would give them 10 grams, and then they'd add that 20% onto their original amount. So they'd do 50 grams plus 10 grams to get 60 grams. But that's still quite a lot of steps. That's quite a lot to think about for someone who's not too confident with percentages. And considering what we said at the start of this video, so most learners can process around 4 pieces of information at once. That has quite a high intrinsic load if you're not very confident with percentages. So with enough practice, when our pupils begin to master a skill, it reduces their intrinsic cognitive load because after a while, instead of seeing a skill like this as taking up 3 spaces in the working memory, the process will become more automated and they can just view this skill as just one thing. So some might learn calculator skills to do this in one step, some might be confident to even do it in their heads. So as teachers, we need to make sure that these individual building blocks are absolutely mastered before we apply them to harder, more challenging exam style problems with a much higher intrinsic load. So I had a look on Exam Pro at some science exam questions and I found lots of questions like this. So in my opinion, this question has an extremely high intrinsic load. So please pause the video and just take a moment to read the question and just think, how much are pupils being asked to hold in their working memories in order to get success in this problem? So in my opinion, there's just so much going on here. So let's think about it. Ultimately, it's a percentage increase question. All right, but it's not only that. It's not just calculate the percentage increase of something. It's calculate the difference in percentage increase. And then pupils then need to find test tube 1 and test tube 5 on this table. So their attention's being split between the words and the table. And if that wasn't enough, also it wants them to do something else at the end. It wants them to give the answer to 3 significant figures. So that's so much to think about. And when we think about at the start of this video where we mentioned research suggests that pupils can hold around 4 pieces of information in their working memories at any one time, that's a lot to ask for unless pupils are really confident on each particular building block. So if your pupils find percentage increase challenging at the moment, they're not going to stand a chance with the rest of the problem because some pupils see percentage increase as a skill that would take around 3 or 4 parts of their working memory to begin with. Cognitive overload will happen unless we teach all of these skills individually before piecing it together. So when we're planning our lessons, it is important that we consider this intrinsic load of the problems we're giving our pupils. So if we think of each required skill as a building block, we should be asking ourselves, are our class secure on each of these skills before we piece it all together? If they're not, let's take some time out of a lesson to address each skill separately first. So let's say, alright, I've addressed all of these skills. I think my class are pretty confident at each individual skill. Sometimes classes still find it quite tricky when you piece it together because still, even if you're confident on each of these skills, there's quite a lot going on. Okay, so how can we support pupils when we eventually do get to problems like this with a high intrinsic load? So in the past, what I may have done is found a question, projected it on the board, demonstrated it, rubbed off what I've done, and then project another question on the board and ask my class to try what I've just done. But I'd always seem to run into some problems because no matter how well I feel like I explained the problem, no matter how much a pupil is desperate and keen to listen and learn, there's still quite a lot to remember and pupils will just end up asking me to demonstrate again. Another thing I may have done in the past, I may have tried to get pupils a little bit more involved. So I say, alright, does anyone know what to do first? Sometimes I get some brilliant responses from pupils that get me off on the right track straight away. Other times I'd ask pupils for an explanation at this stage. They'd say something that's completely incorrect and it makes my explanation go off on a bit of a tangent and there's quite a lot of confusion in the room and it really slows the pace down. So to help with problems like this, I've started using example problem pairs, which have been an absolute staple in my lessons ever since I started using them. So the idea is literally split your board into two, present a question on the board, and you demonstrate it from start to finish. Sometimes I do it in silence without saying a single word, just so pupils can really focus on my writing and my annotations, or sometimes I'll explain it as I go. It depends on the question really. So if you plan your example problem pairs carefully enough, it can be a really effective way of easing that cognitive load for your pupils. So first of all, you're just showing them exactly what a good answer looks like. So there's no ambiguity, it's efficient, and the pupils can see exactly what you're looking for in an answer. If you plan your questions carefully enough, so for example, compared to my question and the one I would ask my class to do, I've just made a subtle change. The question's exactly the same, but instead of test tube 1 and 6, I'd like them to calculate test tubes 1 and 5. So the reason I've just made that subtle change is that pupils can now use my calculations when I calculated the percentage increase in test tube 1 from my previous answer, and they can use that in their answer, but then they still have that independent work for test tube 5 that I haven't calculated for them, that they need to apply to the question themselves. So just me helping them out with that test tube 1 straight away has eased that burden, it's eased a bit of that cognitive load that was given to them in the original question with the way it was originally worded. If you wanted to make it slightly more challenging, you could challenge them to do, say, test tube 2 and 5. So in this example of the question, it doesn't use any of my previous calculations, but the fact that I've demonstrated the process will help them make a plan as to how they will solve the problem. If all of that was too challenging, if you feel like you want to test your class's ability just for that particular building block of calculated percentage increase without looking at difference in percentage increase, you could change the question. So you could still use the same table and just minimally change the question. So calculate the percentage increase in mass after 6 days in test tube 1. So just focusing on one test tube. So it's just atomizing that building block. So it's a really nice way to be really responsive to your class. It's good with mini whiteboards if you just wanted to quickly test their ability. You can ask them so many questions based on this same set of information. So another strategy we could use to help reduce that intrinsic load is called backwards fading. So that's where you demonstrate the entire problem, just like what we do with example problem pairs, and then for the problem that you want your class to do, you can start it for them and then ask the pupils to complete it. So again, that just helps reduce some of that load that you're putting on their working memory. So it's just completing some for them, asking them to finish it off. So backwards fading, that can just be seen as a nice way to bridge the gap between you demonstrating the problem and then them trying an entire problem independently. So we've talked about intrinsic load. Now I'm going to talk about extraneous load. So I'm going to define it and then I'm going to talk about some strategies we could use to help reduce it. So extraneous cognitive load, this could be defined as any load that is not necessary for learning. So let's go back to the exam question that we were looking at. So let's imagine I'm in a lesson and my ultimate goal is I would like my pupils to be able to calculate a percentage increase. Do I really need to present them a question which requires them to practice their rounding skills? Do I need to give them questions where they actually need to extract the figures that they need to calculate from a table? Because I would argue, well, all of this information flashing blue at the moment, that's quite redundant. That information has no bearing on the calculation that they're going to be performing. So asking the pupils to extract the information from the table, that adds one more job that they need to do. That's one more thing they need to think about in their working memories, which we know is already limited. So I'd argue that is an example of extraneous cognitive load because it doesn't need to be there. So here's another example of a question. So it's calculating percentage gain or percentage loss. But again, instead of just giving the pupils the figures, and they're needing to extract that information from a table. So again, that is going to add one more thing that they need to do. That could be the difference between clogging up their working memories to the point where they can't complete the question anymore. So I'm not for 1 second saying don't show pupils exam style problems. Of course we need to, because they're going to be doing an exam in it by the end of year 11. But I'm just saying in the initial acquisition phase of their learning, so when they're first encountering a topic or skill, we don't need to be showing them questions like this until you know they're confident with the building blocks. Right, so anything else apart from that initial skill, currently in the early phase of their learning, is just extraneous cognitive load that they don't need at that particular point in time. So another really easy way to reduce extraneous cognitive load for your pupils is to just declutter the resources that you use. So let's say you've tried to find a resource online, so I might just find a maths one just like this. All this stuff on the top, that just doesn't need to be there. That's not adding anything to my explanations. That's not helping my pupils solve the problem. Do I need to write starter there? If the word starter's not there, are my pupils going to think it's the end of the lesson? No, they're not. Well, they know it's the starter. Do I need to write task there? I don't. Just all I really need is the question. So from this same PowerPoint, from this resource I've just found online with a quick Google search, again, it's just so cluttered and there's so many things that I don't need on this screen. So it's a ratio problem where pupils just need to find an equivalent ratio to 4 to 5 parts. However, they've dressed it up with this context about a fruit drink and mixing lemonade, squash with water and things like that. But I don't really think that needs to be there. So there's so much on the screen that doesn't need to be there. All they actually need to think about and solve this problem is this. So I've gone from all that clutter on the screen to just this. I've just extracted the actual problem. I've extracted the actual maths. Okay, so I completely agree. Pupils need to be able to read a word problem and extract the maths out of it. Absolutely. They need to do that in their GCSEs, and we need to show them questions like this at some point. However, so I'm arguing in the initial phase of learning, so when you're first teaching them a topic, so for example, if I was first teaching my class ratio, I need to get rid of all these distractions. I just need to show them the pure maths to make sure they can actually do it before I apply it to something like a worded context, for example, because anything else apart from this is currently a distraction and it's extraneous load that they don't need at that particular moment in time. So if I'm introducing it, I might go for an example problem pair, something like this. Okay, and just other things you can think about, and just really easy wins. Just ask yourself, do you need the learning objective on every slide in a resource, for example? Because again, that's just one extra thing that the pupils might find themselves reading as opposed to like focusing on the problem. And just like annotations, pictures, animations, like if your main resource to teach is a PowerPoint or like using the projector like a lot of us, just ask yourself, are these things distracting? Is that just one more thing that might divert the pupil's attention away from what you're trying to do? Because anything that is not necessarily, that's defined as extraneous cognitive load, and it's one more thing that they could be thinking about that is not what you're trying to draw their attention towards. So I'm going to conclude with what I started with really. So remember we said learners can generally process up to 4 new pieces of information at once. And we said that once working memory reaches that cognitive load, no learning takes place. Right, so I'd like to conclude with this. As working memory is limited, let's focus people's attention on things that really matter while removing everything else. If we ensure our pupils have sufficient background knowledge of the skills needed, we will help to reduce their cognitive load and therefore increase their chances of success. Thank you very much for watching, and I hope this was useful.